everyone. I am Dr. Karthika from Department of Biomedical Engineering, SNS College of Technology, Coimbatore. Today, our students of 3rd year Biomedical are going to display the frequency response of ECG QRS detection and to perform transforms on ECG, EEG and EMG using MATLAB. Shall we start?
So now we are starting with the transmission of ECG, EEG and EMG signals. These three are basic biomedical signals captured, and now we are here using the transmitted to these signals are transmitted with wired or wireless. These are prone to noises, so we are using MATLAB to analysis these frequencies.
So as we all know, MATLAB is actually used for image processing and stuff. So as of biomedical engineering, ECG, EMG and EEG are the various signals which are collected from our body. So for example, here is an example MATLAB code for transmissions of ECG, EMG. First we clear and close all the existing ones, and then sampling frequency. We set a frequency of so and so hertz and so and so seconds, and then generate synthetic signals replaced with the real data. We are actually stimulating signals which are like the original ones, and then for ECG signal we have the particular radiant set, and also for EMG the same, and EEG. So these three are the certain formulations where you involve sine waves and cosine waves. So these are ECG with noise. So to remove that, we are going to do loop through all the signals, and we name them as ECG, EMG and EEG for the convenience. And here, time domain plot. So there's a plot which will be the output of this one. So the figure includes subplots which indicates the amplitudes and the time periods. So here X label is time and Y label is amplitude, and the title of the plot will be signal time domain, and then frequency analysis using FFT. This is Fourier transforms where we can get good frequency ranges. So L is for the length, F is for the frequency, and the other formulations include the other subplots which are frequency spectrums. So we'll see the output of the. So this is an example output of ECG, EEG and EMG. So followed by this we will move on to ECG QRS detection.
Then next experiment is going to be ECG QRS detection. In this experiment, we are going to stimulate the ECG signal and remove noises for analyze and diagnose the heart arrhythmias. ECG is the heart electrical activity. QRS complex is the part of ECG, which is depolarization of ventricle. We are going to stimulate ECG signals synthetically. Then remove noises which is consistent in the ECG signals. Then we see the output.
So coming on to the program, our first step here is to produce a sampling ECG signal with a frequency of 360. Usually ECG signal is produced with a frequency of 360 and then a duration of 10 seconds with the time axis varying from 0.1 to 10. And then our next step is to produce a synthetic ECG signal which has characteristic like an ECG, that is our T wave, QRS wave and then P wave. And then our next step with a random noise. And then our next step here is to filter the required frequency with no noise. So we are going to use a band pass filter here to get an ECG signal with frequency ranging from 0.5 to 40 hertz, and then we are going to process it using derivations and squaring, so that we can remove any unrequired noises and artifacts from the ECG signal. And then we are going to threshold it so that the QRS will stand out from the produced ECG signal, and then the plot lines which will make the QRS peak stand out from the produced output. And so let's run the program. So this is the output, and as you can see, these tiny red circles here is the QRS detection. Thank you.
So this was a good session about clarifying how to use a MATLAB and stimulate signals, especially biological signals. So thank you everyone.